Today, I'm pleased to introduce today's session, Fueling AI with Great Data, and our guest speaker, AJ Steers. Aaron Steers, is a staff engineer at Airbyte. AJ has been building open source data software for 4 more years and has contributed to Meltana, Singer, PipelineWise, and other open source projects. AJ has previously worked as a data engineer and architect for large companies like AWS, Amazon Video, and Starbucks. But his real passion is for open source and bringing best practices to the wider data community. When not building software or data systems, AJ enjoys singing with the Seattle Esoterics and playing with his 8-year-old son and his dog, Pip and Stall. I mean, just Pip. Welcome, AJ.
Thank you. It's great to be here. And thanks everybody for joining. And thank you for that great introduction. I'm going to talk today about fueling your GenAI projects with great data. I'm also going to be talking about getting from prototype to production and building on a firm foundation that will scale with you as you add complexity, scale, and new requirements to your data pipelines. So yeah, I'll introduce the concept of ELTP. If you've not heard of that, you might be able to guess what it means if you're familiar with ETL or ELT. But either way, I'll walk you through that. And we'll talk about the new PyAirbyte and Milvus Lite offerings and how they can work together. So without further ado, one final note is that if you have questions, feel free to drop them in the Q&A section. And we will check on those periodically, and we'll also have a section, a place for questions at the end. So yeah, drop those in the chat, and we'll make sure we answer all the questions that we can. Thank you. All right, so just quick introductions. Christy already gave me an introduction, so I'll speed through this a little bit. But myself, I've been a data practitioner all of my professional career, and I love working with data. I love bringing data solutions to big companies and small companies. In my work at the big companies and in consulting, I realized there was just a huge gap in what regular, normally sized, normally funded organizations, and even smaller organizations like universities could do in data without hiring tons of data engineers. So I've really gone deep into open source and trying to bring our best practices that we had at places like Amazon into the common domain, so everybody can leverage that. So a quick introduction to Airbyte. Airbyte is built on open source, has a huge library of open source connectors. And we've been working hard this past year to make sure that Airbyte also scales for unstructured document sources, GenAI use cases, landing data in vector store destinations, and with the release of PyAirbyte being able to run anywhere. So a couple more stats here, just a lot of sources. I'll talk about the distinction of no-code sources and Python-based sources. But just, we're heavily investing in making sure we have all of the connectors you need. And we also have tools for you to build your own connectors, which I'll talk more about. And huge community. We're so humbled by our community. Just hundreds of contributors, thousands of PRs coming through all the time. All right, so quick intro to the different ways you can deploy Airbyte. This will become relevant later. OSS is just our foundational deploy with Kubernetes. You own it, it's on your infra, and that's always available. We also have an enterprise solution that also is self-managed. So if you want scale and you want it in your own infra, but you still want that support, that's there. And then Airbyte Cloud as well. What I love about working with Zilla's and the Milvus product is that they follow very, very similar deployment options to really meet users where they are. And we have recently added PyAirbyte, allowing you to run and prototype pipelines super quickly in Python, which I'll show. Zilla's at the same time not at the same time, but also recently has launched Milvus Lite, which I'll be talking about as well. And both of these aim to make sure that your prototype that you start out with can scale to a full-grown solution without rebuilding from scratch. So what we've been doing at Airbyte and why I think this approach that we're going to talk about right now is important is that when you're sourcing data from a variety of places, You don't want to build something that works for one team and doesn't work for another team. You want to get data from HubSpot. If your machine learning team is writing code by hand and your data engineering team is using some ETL tool, you're going to have fragmentation and silos creating really quickly. So we built PyAirbyte to make sure that all of these use cases could be handled, and it could feel natural for all of these groups who need to build their own solutions. So a quick intro to Milvus. I don't work for Milvus, but they've been great partners with us, and I want to just tell you a little bit about their product. So yeah, it's powerful open source, high performance, highly scalable vector store. As I mentioned, you also have the run local option with Milvus Lite, as well as deploying to either the cloud or self-managed. And that's just important because you don't want to switch tools once you get something that works. And we'll talk about that more. Here's a quick code sample. I'm going to try to make this a theme of this talk. The question of no code or low code. I like to think about just enough code, and so I think this is a great example of just enough code to get the job done. So if you are comfortable with code and you appreciate the benefits of committing your projects to Git, you're going to really appreciate that you can do this with just a few lines of code and iterate from there. All right, so as promised, let's talk about this like low code, no code. I have this principle that I love. It's from Albert Einstein, purportedly. Everything should be as simple as possible, but no simpler. I use this constantly as I'm designing and as I'm developing products. I ask myself, what am I providing here that is boilerplate that could be removed? Where am I adding value or definition that contributes to the process, or where am I providing glue code that really doesn't need to be written by me? Another way to ask this question is, am I writing code that somebody else wrote already? And why am I writing it over again? Why am I reinventing the wheel? I think the answer here is to focus on composable pipelines that have simple and obvious steps in them, and that also break in expected ways, easy to fix ways. We'll talk a little bit about that in a sec. So just as you're getting started with GenAI pipelines or data pipelines, wherever you're coming from, there's a little journey that I want to take you on that has been a very personal part of my life the last 20 years as I've been working in data. And this is the journey of ETL to ELT. For those uninitiated, ETL was basically the catch-all term for getting data from somewhere to somewhere else. And it just kind of happened as extract and load, transform and load. But the problem was with that approach is that you have certain operations like sorting, joining, whatever, that really shouldn't be done in flight. And if this part fails, then you haven't loaded your data. So switching these extract, load, and transform means you have a very simple extract load process that can be repeated over and over again. It can be created incrementally. And then your transform steps, whatever those need to be, happen after you've safely extracted the data. So this is by far a strong pattern. I definitely recommend you examine existing systems and see if you can take this approach. And then I'll add one more here, which is especially for GenAI pipelines, but also for every kind of data pipeline you're building, you want to think about the publish step. There is almost always a publish step. It might be simple. It might be telling your users, hey, come and get the data. Or it might be copying or renaming data sets from their interim name to their production name, removing the schema. Or it might be pushing data to a vector store. And it's important to think about this process and have good terminology for what you're building so that you can have good design underneath. And here's what the design generally ends up looking like. Whatever your raw data is, landing to wherever your vector store is, and then landing in Pinecone or Milvus. Sorry, this slide needed to be updated. But wherever your vector store is, you have extract, load, transform, and publish. All right, so let's get started. I want to give you the intro of PyAirbyte, and I'll do it in some code steps here. So we're getting data from anywhere, and I want to show you this is the example of just enough code. We're only really providing code here that is describing what we want or how we're going to get it. Airbyte uses this get source function. PyAirbyte is what I'm showing. Uses get source, provide the name of a source and some configuration and your streams. And you can also print the available connectors if you are unsure what the connector names are. I'll show that in a demo in a second. You can separately set the configuration or change the configuration after you create the source. Really, this, and then finally, after you've read the data, you can send it to pandas, to SQL, or to documents. We're going to talk about to documents today because we're working on GenAI use cases. But you might also be analyzing your data in pandas, or you might want to query it as a SQL table. All right, and here's the combined version where it gets all three of those steps, getting the source, configuring, and selecting your streams and reading the data all as one step. So again, just the right amount of code. Okay, so I want to pause right here and do a quick demo. So here I have a Jupyter, Colab notebook, which is built on Jupyter. And I have already installed Airbyte. And just quickly say Airbyte, import Airbyte as AB. And then I can check the available connectors. So I can see available connectors is a long list of sources. And this is a huge list contributed by our fantastic open source community with a select number of connectors that have really high volume and important use cases, also certified and supported by Airbyte itself. The only way anybody can scale to this volume is really to use the community's support. So that's why we have such a large library. I also want to say by default, the list we're getting here is the Python installable or pip installable list. If I want to get the larger list, I can put Docker in here. It's actually, if you look at I think it's install method, is that right? It is install type. Yeah, but anyway, just putting the word Docker here is fine. Or you can say install type equals Docker. And this, if we check the length on this, this is a longer list of connectors. So 289 sources right now that you can install just with the same method. So the value here is pretty large for you to have this in your toolbox. There's one more type of connector, which is our YAML connectors. And what this means is that this doesn't even require a pip install. You can just directly run these connectors. Let's say you don't have virtual environment support and you don't have Docker available in your runtime, these connectors can be run directly with PyAirbyte and not requiring any additional installs. And that is powered by our connector builder, which allows you to use a UI to develop your own connectors, directly. Let me see if I can get that up real quick. So I'm going to connect to a local version of Airbyte just to demo what that low code builder looks like. So here I'm running Airbyte locally on my machine. I'm going to go to the Builder tab, and here I've designed a Rick and Morty API. I don't know if we have any Rick and Morty fans, but whatever your API is that you want to develop, you can do so here. Let me hide the sidebar real quick, and I'll show you that all I had to do to develop this API, to this extractor, is go to my API docs, find the base reference, and then define one or more streams. I went to the character URL path. I said the record selector is results, the primary key is ID. And just by going through these steps, I can basically build my own connector with any API. And then all I have to do to install this is just copy paste the YAML. What I love about this personally is that, again, I didn't have to write code by hand, but I still have an artifact I can commit to source control. And this, like I said, this now powers 100 and what's the number again? It's a very large number of connectors. Let's get back to here. So 139 connectors are built that way, and you can build your own. That's what I want you to know. So next time you think about building extractors from scratch, I hope you'll consider this as an alternative. You'll have less code to maintain and you'll benefit from all of these built-in capabilities. So here I have a simple get source method. If I run get source, it will read the data with whatever configuration I provide. I'll show GitHub in a second, but for right now, I'm just going to show this faker data set. And then if I want to get the SQL table behind it, I can. And if I want to convert it to pandas, I can just run 2 pandas. And as I mentioned, we're also going to show 2 documents. So this is just a very quick and fast way for you to get data from anywhere into your Python environment. Or if you don't need Python, you can use Cloud and load it to any data warehouse that you want. Or you can use the OSS offering, as I was just showing, by installing locally. Yeah, so that is the intro demo. Let's continue on. All right, so I do want to show this. So with Milvus and with other vector store destinations, you can use Airbyte Cloud to define a vector store destination. And if you use this option, you can just use our built-in interface to define your chunking and your embedding. Yeah. All right, so I just did this demo. I decided to do that 1 second earlier. So we'll move on to the next topic, which is converting records to documents. So if you've been working in data and you followed us so far, you know, okay, we found a way to get data from all of the data sets we want, whether it's Salesforce or HubSpot or a CSV file or another database or GitHub or, you know, you name it, internal websites. I was talking to somebody yesterday about connecting data from Internet of Things using REST APIs that way. Yeah, so your imagination is the only limit. So getting that data then into document format so you can use it for an LLM is the process really of describing what you want the final document to look like. PyAirbyte has built-in support for that, and I'll show you what that looks like right now. So for this, I'm going to switch over to my second notebook, and I'll just walk you through the steps real quick. We did the install of Airbyte. We're also installing PyMilvus, which we'll show in a second. And then we're going to follow similar steps. So here is, actually, let me hide the sidebar and bump up the font a little bit and hide this. Okay. So so this part of the demo basically calls the same thing we did with the faker data set, but now we're getting real data from GitHub. So we store that in a read result, and I'm running it right now. You can see in real time as it's extracting data. This is running incrementally, which is a fantastic benefit over other methods that you might build by hand. All of our source connectors just come with incremental extraction support. So this will save you tons of time. If you know anything about getting data from GitHub, it's very high rate limited. You're always going to run into rate limits, and it's pretty slow the first time. If for any reason you do want to refresh from scratch, you can do forceful refresh equals true. And then this will ignore your incremental data and just get a fresh data set for you. So yeah, tried to make it super easy for everyone. And also giving you the nice defaults, but override where you need it for the behavior you're looking for. So here we're able to extract our issues data from source GitHub. If I wanted to also get pull requests or stargazers, I can just add those to the streams and it will sync those as well. One more thing while this is running, we made the decision with PyAirbyte to use DuckDB under the hood. If you're not familiar with DuckDB, it is a very, very powerful, very fast local SQL database that also scales really well and runs great in the cloud. So if you do not specify a different data store, it's just going to store it locally in a DuckDB database that's always going to be fast. This means you're never going to run out of, you're never going to crash due to lack of memory or the data set is too large. Okay, so then I just want to demo looking at a record. Let's say I want to look at, let's say I just want to look at the first record. So let's say first record. Okay, this is, you can see this is rich data about a specific issue. But now let's say I want to render that as a document. here is a two documents interface that gets it ready for the LLMs, and this is going to help us in the next step. So what I'm doing here is just taking the same read result, running two documents on it, telling PyAirbyte what I want to treat as the title or contents and metadata. And then if I want the metadata to appear in the document, which I do. So here is my transformed document. Here's the title of a specific issue. Here is the issue number, the state, and the URL. These are metadata. And here's the body of the issue. Great. So now I've basically translated this. Where was it? I translated sorry, I'm getting lost a little bit, but I translated that here it is, this first record, this very, very long JSON thing into something that I and my LLM can use more reliably. So that's why that's important. Okay. So I'll save this last part of the demo for a little bit later, and we'll switch back to the slides. Okay, so now we've seen how to extract data. We've seen how to analyze that data locally in a Python notebook, and now we've just seen how to convert records into documents when we're using them for LLMs. What I want to demo actually, yeah, I guess this is the next part of the demo. So let's switch back to this last bit. What I want to show you now is building the Python prototypes that scale. So what I want to cover here is a GenAI pipeline using everything we've built so far, but then also building the GenAI part of it and building in a way that we can deploy it to production. So here's where I'll bring in Milvis Lite.
Hey, AJ, I have a question.
Yeah.
So, like you're coding everything in Python,
Yeah.
and then I noticed that there's a PyAirbyte that's still in.
Yeah.
Do you know when that will be released as GA?
Yeah, thanks for that question. So why Python first? So Python is quickly becoming the de facto language for data science, or at least a very, very popular language for data science and Gen AI. It has always been popular. I think previously R was the most popular for data science and ML, and Python has pretty much supplanted it. There's also new investments in Python ecosystem, such as the upcoming much talked about Mojo, which is a superset of Python. And if you look at the documents around Mojo, they are also acknowledging that Python just has a huge ecosystem. What I personally love about using Python is just that it is innately readable. And when we talk about just enough code that you want, I think that's a great example. It's generally very concise and easy to read, which means everyone can review it and contribute. We're not against other languages. People have asked, will we create a TypeScript version for PyAirbyte or TypeScript Airbyte? And we're not there yet, but definitely if that's something you guys are interested in, let us know. The other part of the question, I think, was a PyAirbyte being
Yeah. Oh, yeah. When is it going to be GA?
Yeah, so we're planning that for end of this quarter. We went through an initial phase of basically launching PyAirbyte and having a huge number of community members come through and test it with every source, including sources they were making themselves. And through that, we found some edge cases, which we've improved on. Stability-wise, we're getting to a really good place. And so that's not a concern. What we'd love right now is more feedback from users on, is this the API you love, or would you suggest any changes? And once we feel like we have a stable API, I think we're going to go into GA for PyAirbyte. We're expecting that in H2 of this year. So that might be Q3 or Q4, but coming before end of this year for sure.
Thank you.
Cool.
I'll go.
Thanks. Yeah. And any other questions as of now? You are muted now.
I don't see any more questions in our little GA.
Yeah, great.
But all I know
I'll continue on then. Great, thanks for those questions. Okay, so here we are now integrating with Milvis Lite. All of the things that I mentioned about PyAirbyte and the benefit of being able to run in a notebook, and then as I've been kind of alluding to and hinting to, you're writing in a Python notebook code that you can also productionalize, or an interface and a design that you can also productionalize. When we talked about ELTP, one of the benefits of having EL as its own thing is that you can easily move that thing. It's not going to fall down. It's not going to, run out of memory. It's designed to be resilient. And then we're going to talk about some transformations and publish operation, which you can, right now we're going to do it in Notebook, but in the future, as you scale, you could put this in Zilla's cloud, and Airbyte cloud, or however you decide to end up deploying your final solution. All right, so while this is rerunning right now, I'll just walk you through the code real quick. So this first step, we're going to say from PyMilvis model dense, we're going to get an OpenAI embedding function, and we're just going to define that as the embedding function from OpenAI. Airbyte has built-in secret support, so it's going to get the secret in this case from Colab secrets, but it will automatically also get secrets from your environment variables or your .env file. We just want this to be really streamlined and also really secure. So here we go. It looks like we've successfully installed packages, and we've successfully created a list of vectors. So what we did here, oh, I accidentally ran the whole thing again. That's okay, it's going ahead of us. It's nice when the code runs quickly. So here, just we're encoding the documents. So the docs up above were where we said 2 documents on the data set. This interface is also fully compatible with LangChain. We partnered with LangChain to make sure that 2 documents generates documents that you can also use in LangChain, Llama Index, and other tools. You can just hand off the documents. In this case, we're taking the content of those documents, turning it into a string, getting some vectors out of that by running the encode documents function. And these vectors, actually, let me just print them real quick so we can see what they look like. So as you might imagine, there's just a huge list of these floats corresponding to the documents that I encoded. And now with our Milvis client, we're going to create a local Milvis instance or database. This is great because I don't need to worry about side effects in my production system or my prototype. I don't have any infrastructure to manage. I can just directly run it, including dropping whatever I was doing before in my last iteration, creating a new collection. And then for number of dimensions, I can just use the number of dimensions in the dimensional model. So running this will store the data in the blob. I can print out the number of dimensions, which is 1536 in this case. And then lastly, inserting the data. Well, not lastly, because we're going to benefit from it in a second, but here's lastly to get the vector store destination published. All of what we're doing right here can also be done in Airbyte Cloud with no code. But in this case, we're just showcasing how to do this with PyMilvis. Or Milvis Lite, I mean. Okay, so we've loaded data here. Let me just show you here the insert statement. We give the collection name and we pass the documents that we created earlier. Yeah, so now it's time to get some value out of here. So, so what we want to do is we want to take a question, summarize issues related to Spark interop. And from that question, we want to find any related issues and summarize them. So we do milvis.search, give our collection name, the data, how many entities we want to return, and then what fields we want. So I'm not going to review the printout, but I'll show you what happens when we run this. So you should see that here is the summary. In this case, I'm using OpenAI to make a quick call. And so it tells me there are 2 open GitHub issues in this repo. Issues pertain to a feature request and documentation task. Add Spark to dataset and summarize PyAirbyte personas. So here I've successfully used, I can ask any question I want now to my data, and I can prove out, does this work as I expect? Once it is working as I expect, we can talk about promotion, but this is basically a fully contained end-to-end data pipeline, extract, load, transform, and publish ELTP all in one notebook. And if you would like to see this notebook, or let us know, we can share the link with you. Yeah, just drop a note in the chat. Okay, and let's switch back to continue. All right, so as I've been hinting to along, it really matters what choices you use when you're building your prototype, as to whether you'll be successful when you try to get into production. I mentioned I've been in the data field quite a long time. I've seen firsthand ML projects and AI projects never get to production after months and months of effort. I think the success rate of deploying AI projects or ML models into production is something like less than 20% success. Somewhere, I think the estimates are somewhere between 80 and 95% failure to get to production. So if you want your prototype to have a higher chance of getting to production, building on a good foundation is really what you want to do. And so everything I showed was easy to get started. You run it in Python or wherever you prefer to run it. But now you have those composable steps that could easily be handed off to your IT group or be put into a production pipeline in the cloud. So if you I use the matrix thing here, but but yeah, if we don't want to have to go back to the beginning and forget and start again. We don't want to take a chance that okay, what we built very carefully in our prototype will be rejected by our IT team when we try to deploy it. We want to build on a foundation that that can be deployed, and everything I demoed today are things that you can easily just migrate to the cloud or push to the cloud when you're ready to do so. And that's harder to do if you write your custom code. I have personally seen people develop solutions and nice drag and drop canvas interfaces, and they try to hand that off to the IT team, and they're like, "No, I can't support this. Sorry." And we've designed PyAirbyte to have good design choices, and I think Milvus Lite is a great tool to use with a clear path to production and highly scalable when you deploy it. So benefits of building on ELTP, like I said, you don't want to have to migrate or rebuild your tool, but you do want the friendly, quick and easy to iterate in Python or whatever language you choose. And with the approach that I've shown, whatever works, whatever experiments work, you can just promote them, and whatever does not work, you can let it go. And it's not a lot of code to support either way. One thing I didn't talk about is CI/CD and Git ops and things like that. But if you're a fan of Git and CI/CD, everything I've shown right now works really well with CI/CD. All right. Well, I think that is it. Let's pause for any further questions, and yeah, then I'll wrap up.
Okay, it's a very quiet group this morning. Just checking chat and questions.
We'll give people a chance to put any last questions while I do just go through a couple more things. So yeah, so
Well, I have a quick.
Oh yeah.
So you mentioned something like 285 connectors.
Yeah.
Are you seeing types of YAMLs? Are there certain connectors and types of connectors that you are seeing as very popular?
Yeah. So unstructured data sources have been really popular because text is now data, or we can now treat text as data. So this is not necessarily the YAML or low code, but we've invested in Google Drive, S3, Azure Storage, all of the places you might store a PDF or a Google Doc or something like that. And now if you want to say, hey, what was that document from a month ago where we were talking about design patterns? You're very likely to be able to find that and find insights on it through RAG. Another one that's really popular with the no-code builder is building for internal endpoints. Almost every company, if they have a decent sized infrastructure, will start building their own APIs for internal use. And those are things you're never going to find an out-of-box connector for. because you literally built it yourself. And you also don't want to build from scratch the analytics, etc. So we find that the no code builder and the custom connectors that are really popular sometimes are the ones that only matter to you. But like the fact that you can build that yourself is also really valuable. So I list, I think, with 280 connectors, but we know that people have built thousands of connectors. They're just not all worth publishing to external to the community. But yeah, great question. Am I coming through audio? I think I. All right, so I'm gonna say thanks and wrap up. I might have lost Christy, or I might have been disconnected. Am I still on? All right. Well, I'm going to wrap here. Thank you everybody for joining, and I hope you've enjoyed this topic. If you have any questions for us, feel free to reach out. We are on Slack. And yeah, thank you so much, Zillis, for hosting.
Oh, sorry.
Thank you, Christy, for hosting. I just said goodbye to everyone, and I think we lost you for a second on the video.
Yeah, I wasn't sure. I saw the frozen screen, and then I was like, "Oh no, is that yeah? What's going on?"
Oh yeah, so I just wrapped up, and I said thanks everybody for joining, and I think we
Oh,
can wrap it if
okay,
that
so
works.
sorry about that.
Oh no, you're fine. You're fine. Yeah, I thought it was me.
Um,
Yeah. Well, thanks
yeah,
again.
I was like,
Oh, sorry.
okay, okay, well, all right. Yeah, I don't know. But these things have a longer tail than what the live audience is,
Hmm.
and so they end up going out on YouTube
Hmm.
and getting a lot more views in the long tail.
Yeah. All right.
Yeah. So
Well,
thank you for doing this.
thanks. Yeah. No, I appreciate
Yeah.
it.
And then, oh yeah, and then in your slides, can you change that
Oh,
pinecone logo?
yes. Sorry.
And with
Okay.
the
Yeah.
replacement would be Zillow's,
Yeah.
because Zillow's managed open source Milvus.
Okay. Great.
Uh, yeah, so and then we'll share our. I'm sorry for my internet glitch.
Okay. Yeah, I lost a little bit of what you're saying, but we can catch up in Slack. Thank you so much.
Okay,
All
thanks.
right. Bye.